So today we're going to be solving absolute value equations. And one of the big ideas that is new with absolute value equations is many students like to treat them like a set of parentheses, which in one sense is true, but these are parentheses with an extra power. These parentheses mean that when I solve for whatever's inside, I have two possible values which can equal the thing outside. We know the fact that if I have something like -7 or +7, are both going to equal the same thing of 7. So when we solve this in an equation format, that means to get the answer, we need to solve for two separate versions of the answer. And now, one way is to break this and take a positive and negative version of what's on the inside. Most often, we actually flip that process and take the positive and negative version of the outside. Whichever way you like better is the way that you can do. However, in this video, what we're going to show you is we're going to isolate the absolute value brackets, rewrite the absolute value brackets twice, take a positive version of the outside and a negative version of the outside, and get our two possible values for x. So let's see what that would look like in action. Now, with this set of absolute value brackets, it is already isolated. So what I'm going to do is I'm going to split. So split. I'm going to split it into a positive version. So 6x is a positive 42. And then I'm also going to get a 6x is a negative 42. Like I said, I split it into two versions of itself. And I'm going to solve each one. So I have the positive and the negative. When I take that, I'm going to divide each side by 6. We know that each side divided by 6 is going to net us a 7. So I get x equals 7. For the other part, when I divide by 6, I get x equals -7. So I know that if I plug in a positive 7 or a -7, I'll still get the value of 42. And one of the most important steps when solving absolute value equations is this is the first chance you're going to get to see what we call extraneous roots. And so I'm going to double check by plugging these in and say, okay, the absolute value of 6 times 7 is 42. That's the absolute value of 42. Yes, that value works. I'm also going to plug in the -7 and say 6 times the absolute value of -7 is 42. Absolute value of -42. And 42 is 42. And yes, that checks out. So both these roots work. Now, today we're not going to see really any of these, but in a future section, you're going to see values where you're going to get a positive and a negative version of the answer, or something that is a not true statement, which means that this is, in layman's terms, a false positive. It looks like it would work, but when we try it out, it doesn't. So let's try this one. Now, my absolute value bracket is not isolated in this case. So what I'm going to do is I'm going to divide both sides by 7, which is going to isolate my absolute value. Let's see, 7 goes into 56 8 times. Now that my absolute value brackets are isolated, I can split. Actually, I'm going to box these up just so it shows that, cool, I have a split, which means I'm going to say n is equal to a positive 8, and I'm going to say n is equal to a -8. Luckily right here, there's no further work involved. I have my two answers. Now I just got to double check. So when I first check, I'm going to plug my positive value in and see what I get. So 7 times 8 is 56. The absolute value of 8 is 8, and 56 does equal 56. We know that answer works. We do the same thing with the negative answer. I say 7 times the absolute value of -8. The absolute value of -8 becomes positive, and 56 again equals 56. So that checks out. And we just want to get into a good habit of testing our values so that we know when we see an absolute value bracket, we're going to check to see, is it a false positive? So right here, our absolute value brackets are isolated, so I'm going to split. It's going to give me two different equations. Y minus 54 is 37, and y minus 54 is negative 37. If I solve both of these, I'm going to add 54, add 54. It's going to get rid of that. I'll have y equals 91. I'm going to try that out here in a moment. For my other answer, when I add 54, signs are opposite, so I'm going to subtract. 54 take away 7 is going to net me with a 47, minus 30 is going to net me a 17. Ooh, let's do this in black. Y equals 17. Perfect. And so let's test out our two possible answers. If I plug in 91 into this equation, 91 minus 54 is 37. See, 91 minus 50 is going to be 41. 41 minus 4 is going to net me 37. The absolute value of 37 is 37, which checks out. So now that's one answer. For my other answer, I'm going to plug in 17. 17 minus 54 is 37. 17 minus 54, so let's see, okay. 54 take away 10 is going to be 44. 44 take away 7 is going to be 37. The absolute value of negative 37 is going to be positive 37, which checks out. Both my answers work. And so now what I want you to try is I want you to try the same process on this next set. So go ahead, pause the video, try number 7, and see how well you do. Unpause when you're done. Okay, let's see how well you did. So what you should have first noticed is that your absolute value brackets are not isolated. So I need to get rid of this 44 before I can split it, which is going to cancel that one out. And I'm left with the absolute value of x is equal to, let's see, 110 minus 40 is going to net me 70. 70 minus 4 is going to net me at 66. And now that that's fully isolated, I'm going to split. And that's going to net me x equals 66 and x equals negative 66, which conveniently enough are already solved. So let's plug those in. I'll plug in my positive 66. Plus 44 is 110. The absolute value of 66 is 66. Let's see, 66 plus 4 is 70. 70 plus 40 is 110. Our first answer checks out. If I plug in negative 66, the absolute value of negative 66 is positive 66. 66 plus 4 is 70. 70 plus 40 is 110. That checks out, and so does my other answer. Awesome. And so far these have been one or two steps. Well, actually those have all been one step. So let's try a two-stepper. This is a two-step absolute value. First step is going to be to isolate the absolute value brackets by getting rid of this 13. It's going to get rid of that. And we have the absolute value of 7y is equal to, let's see, 83 minus 3 is 80. 80 minus 10 is 70. Cool. And so now that the brackets are isolated, we're going to split. That's going to give me two different equations. 7y is 70, and 7y is negative 70. And with both of those, what we're going to do is we're going to divide them by 7. That's going to net me on my first equation is y is equal to a positive 10. When I divide by 7 on my second equation, that's going to net me a y equals negative 10. And now that we have our two possible answers, I'm going to plug them in to check to see if they work with our original scenario. So let's go ahead and plug them in. So if I plug in a 10, 7 times 10 plus 13 is 83. 7 times 10 is 70, plus 13 is 83. Absolute value of 70 is 70. 70 plus 13 is 83. That checks out, and so does our first answer. When we plug in our second value of negative 10, let's see if that works. Now 7 times 10 is a negative 70. The absolute value of negative 70 is positive 70. 70 plus 13 is 83, which checks out, and so does our second answer. And so what I want you to try is I want you to pause the video. I want you to try number 11 and see how you do. Resume the video once you're finished. Okay, let's see how we did. So one of the first things I notice is that my absolute value brackets are part of a fraction, which means I need to get rid of that fraction. So I'm going to multiply everything by 8. And I know the fact that this 8 and that 8 are going to cancel out. I'm left with just absolute value of negative 4 plus n. This does not cancel out. So now 6 times 8 is going to be 48. Boom. Now that's isolated. Once I've isolated it, I'm going to split. My L and my I's got backwards there. Dyslexic much. When I split this, I get a negative 4 plus n is a positive 48. And then I'm going to take my inside and say negative 4 plus n is a negative 48. I'm going to solve both of these. So for my first one, I'm going to add 4. I'm going to get rid of that. And I'll have n equals 52. There's answer number 1. For my other one, I'm going to add 4. Because these signs are opposite, that's going to give me an n equals negative 44. That's my second answer. Let's try both of these out. First, I'm going to plug in my 52 and see what I get. So I get the absolute value of negative 4 plus 52 divided by 8 is 6. Negative 4 plus 52 is 48. Absolute value of 48 is 48. 48 divided by 8 is 6. So my first answer checks out. My second answer of negative 44, absolute value of negative 4 minus 44. Negative and a negative are just going to make a bigger negative. Absolute value of negative 48 is going to be positive 48. And again, 48 divided by 8 is 6. My second answer checks out. And there we go. So today what we're doing is we're doing absolute value equations, but we're doing a more advanced set. And so we're going to see the fact that each one of these has multiple absolute values. Now, to start out, what we're going to notice is that each of these absolute values is, in fact, the same thing. So one of the ways that we're allowed to look at this, if this confuses you, is we're allowed to replace anything in an equation, as long as it's the same thing, with a subsequent value. So what I'm going to do is I'm going to say that, hey, box is equal to the absolute value of 8x. And what that allows me to do is that's going to say, hey, 4 of this box is equal to 3 of this box plus 64. And what this allows me to do is this allows me to look at the absolute value in such a way that I can combine it. And I can say, okay, if I have 3 of these things over here, well, why don't I just go ahead and take away 3 of these things on both sides? What that's going to allow me to do is say that I only have 4 of this box. No, not 4 of this box. That's going to be 1 of this box. Ignore that. 1 of this box is equal to 64. And we know 1 of anything is just that anything. So I have my box is equal to 64. And then what I'm going to do, because I plugged this in, I'm going to take it back out and say, okay, what actually did my box stand for? It stood for 8x. So the absolute value of 8x is equal to 64. And the reason why I picked box is because oftentimes it's very easy just to connect the two bars. You can pick anything you want. If you wanted to say the absolute value of 8x is equal to y, you could replace it. If you wanted to say n, you could replace it. I literally just say box because graphically it's very similar. And we know that once we've isolated the absolute value, what we do is we do a split. Okay? And so I'm going to take both the positive, I'm going to do this in blue, and the negative version of my answers. I know that I'm going to have a positive 8x, or 8x equals a positive 64, and 8x equals a negative 64. Remember, what I'm looking for is a positive version and a negative version. To solve this, I'm going to divide by 8 on both sides, which is going to give me x equals 8. I cannot write today. I'm not sure what's going on. So I have x equals 8. Here I'm going to divide by 8, and I get x equals negative 8. So these are my two answers. And we've spoken previously about the importance with absolute value of checking your work. So what I'm going to do is I'm going to take each of these answers and plug it back into, not into the original equation because that would require a lot of work, but into my simplified version. So I'm going to plug it into here. So that means the absolute value of 8 is 64. The absolute value of 8 equals 64. And I'm going to plug in both my answers. I'm going to plug in my positive 8, and I'm going to plug in my negative 8. And I'm going to see what I get. 108 by 8 is 64. The absolute value of which is 64. That works, so this answer is validated. When I do the next one, 8 by negative 8 is negative 64, the absolute value of which is 64. Well, 64 does equal 64, so my next answer is validated. Now again, we're going to see a lot of these today because we're not really going to introduce the extraneous roots until the next lesson. But always check, whenever you see absolute value, always check your work because there is a chance, and there's a very real chance, that your answer will come back with a false positive. So let's try one more like that. Let's hope that I can write a little better this time. So I have these boxes right here. I know I have 10 of the boxes and 7 of the boxes. So what I'm going to do is I'm going to take away 7 of the boxes. So minus 7 of the boxes, which means that I've gotten rid of all my absolute values on the right, and I just have 3 of these boxes on the left. And so you kind of see where we're going with this. I'm leaving it intentionally blank to allow me to manipulate the equation in such a way that I eliminate everything outside of my box or outside of my absolute value brackets. So I get box is equal to 25. Now remember, what was in my box? Well, it was a 5y. So when I split this equation into a positive version and a negative version, I'm going to have 5y is a positive 25 and 5y is a negative 25. Remember, a positive and a negative version. So now when I solve this and divide by 5, I get y is equal to 5. That's one answer. And I get y is negative 5. There's my second answer. And the most important step when solving absolute value equations is to plug it in. So I'm going to have the absolute value of 5 times something, the absolute value of 5 times something. And I'm going to check to see if both of these equal 25. So plug in my 5, plug in my negative 5. 5 by 5 is 25, the absolute value of which is 25. Yep, that checks out. This is negative 25, the absolute value of which is 25. Yep, that checks out. Both my answers check out. So we're good. Now that works no matter how many different terms I have on either side. If I have absolute value brackets on the left and on the right, and I have constants on the left and the right, it's no different from how I treat this. I'm going to treat these brackets like a variable, and I'm going to isolate them, which means I'm going to get rid of 4 of them on the right. And to balance this out, I have to also get rid of 4 of them on the left, which means I have 3. And the next step is I'm going to get rid of the plus 20, which means that cancels out. So I have 3 of these is 180, or getting rid of the 3, what I get is not two of them. I get 1 of them is equal to 60. And we talk about what is 1 of them? 20x. And so if we follow, nothing's different. We're just treating the brackets like an equation, isolated so that we can do the split and make a positive version and a negative version. So 20x is positive 60. There's my positive version. And 20x is negative 60. There's my negative version. Divide by 20. X is 3. Divide by 20. X is negative 3. 2 answers to check. Where do I check? I plug them in. Absolute value of 20. Absolute value of 20. I want to check to see, do they equal 60? Let's plug in my 3. Let's plug in my negative 3. So 20 absolute value of 3 is the absolute value of 60, which is 60. Checks out, checks out. This is negative 60, which the absolute value is 60. Checks out, checks out. Perfect. So what I want you to try to do today is I want you to try to do this on your own. So I'm going to pause the video, give number 7 and number 9 a shot. When you're done, resume the video and see how it went. Okay, so let's see how it went. I have 2 sets of absolute value brackets that I'm going to have to get rid of one of them. Luckily, they're both the same thing, so if I subtract 12 from both sides, that gets rid of all my absolute value brackets on the right. Which means that I only have 2 steps left to completely isolate my absolute value brackets. I have 3 of them is equal to 108. And if I divide both sides by 3, I get whatever is in my brackets is equal to, let's see, that's 3, 6, 36. Now that they're isolated, I'm going to replace my 12y so that I can split it. Positive, so 12y is a positive 36, and my negative 12y is a negative 36. If I divide by 12, y is 3. I got to check that out. Divide by 12, y is negative 3. Got to check that out as well. So my 2 possible answers, I am going to plug them in. 12 times something is 36. 12 times something is 36. The first something I'm going to try is 3. The second something I'm going to try is negative 3. Let's see how it goes. 12 times 3 is 36, and the absolute value of which is 36. Checks out, checks out. 12 times negative 3 is negative 36, which the absolute value of that is 36. Checks out, checks out. Awesome. And so now many of you tried the last one. If you haven't, go ahead and take a quick pause and then resume it when you're done. For those of you who have already done it, we're just going to jump in with both feet. Now, the only thing different with this is that I've noticed that my inside my brackets is not multiplication, but it's addition. It works just the same. I'm going to subtract 2 from both sides, which is going to cancel that out, and I'm left with my absolute value brackets is equal to 10. Which means I'm just going to say, okay, whatever was in there, I'm going to put back in so that I can split. Split over here for a positive, and I'm going to split over here for a negative. So x plus 3 is a positive 10, and x plus 3 over here is a negative 10. Remember, positive version, negative version. If I subtract 3, that's going to go with x is 7. I have to check that one out. X equals negative 13, and I have to check that out. And so what you probably noticed in the last video, and what you notice here, is that when I'm just multiplying, I get a positive and negative version of my answer. But when I incorporate something like addition or subtraction, I get 2 different answers, which again is leading up to why we always check our work. Because not always does it work out. So something plus 3 is 10. Something plus 3 is 10. First something is a 7. Second something is a negative 13. We know 7 plus 3 is 10, the absolute value of which is 10. Check, 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 check. This gives us a negative 10, which the absolute value is 10. Checks out, checks out. And there we go. So today we're going to be working on absolute value equations again, but we're going to be dealing with an extraneous value as a possible answer. The idea behind this is that when we plug in our answers, when we're checking the work, it actually doesn't work out. This is more commonly called a false positive. And the idea behind this is rather simple when we look at it up front. When I look at the absolute value equation, I say, hey, the absolute value is always going to be positive. So is there ever a case where my absolute value can ever equal a negative number? No. So I know whatever answers I'm going to get for this are both going to be extraneous values, because there's no way I can get an absolute value to go less than 0. So let's go ahead and try it out to see what the process looks like. So when I have the absolute value, I know that I've isolated. I'm going to go ahead and I'm going to split the equation. So I'm going to split it. And I'm going to split it into what we call a positive and what we call a negative value. Now, the split positive means there's actually no change. Don't know why my ink is not working today. No change, if you can read that. And then this means we change the signs. So we have one where there's no change and one where we change the signs. So I'm going to write 2 different equations. I'm going to write 9x equals negative 45. No change from what we see. I just don't have the absolute value brackets. And then for my second one, I'm going to change the signs on what's out here. So 9x equals positive 45. This comes around from what happens if I take a negative 45? It becomes a positive. What happens if I take a positive negative 45? Well, it stays negative. And so let's work this out. So if I divide both sides by 9, what that's going to give me is that's going to give me an x equals negative 5. An answer I'm going to have to check out. For this one right here, when I divide by 9, I'm going to get x equals a positive 5. A second answer I'm going to check out. And when I try out these answers, I'm going to plug them into the equation that I actually split. So this equation right here. And we already know that, is there any way that we're going to end up with a negative number? No, but sometimes it's not that obvious. So let's go ahead and plug them in and see what we get. So I'm going to plug in my first answer of negative 5. So absolute value of 9 times negative 5 equals negative 45. I'm also going to plug in my other answer. So absolute value of 9 times 5 is negative 45. Perfect. And let's go ahead and let's work this out. So 9 times negative 5 is negative 45. The absolute value of negative 45 is positive 45. And as we said at the beginning, does a positive 45 equal a negative 45? No, that does not. So I know that this answer does not work. For my other, I get the absolute value of positive 45, which means that positive 45 again does not equal a negative. I know that because this does not work, neither does my other answer. So this is what happens when we check our work. I try and plug it in, and I get something that's not true. And we could have noticed if at the very beginning we noticed that absolute value is equal to a negative number. So let's go ahead and let's try the next one. So with this one, again, my absolute value is already isolated. Again, I see I'm going to get some false positives. But again, we're practicing the procedure here because not all the time will you get just the constant. Oftentimes you'll have variables off on the right-hand side, and we want to incorporate those into this procedure. So if I split into a no change, what we call the positive, and a changed sign, what we call the negative, we'll get the following two equations. No change, n plus 13 is negative 65. This one, n plus 13 is negative 65. Positive. That negative became positive. Awesome. So let's see how we do. Subtract 13. That goes away. So I get n is negative 78. I'm going to try this one out. Over here, when I subtract 13, I get n is 52. Another number I'm going to have to try out. So what I'm actually plugging it into is I'm plugging it into the equation that I split. So both my answers, I'm going to test it into that. So let's see what we get. I'll get the absolute value plus 13 is negative 65. I'll get the absolute value plus 13 is negative 65. First one is negative 78, and the second one is 52. So let's see how this goes. There we go. There we go. So negative 78 plus 13 is going to be the absolute value of negative 65, which turns into a positive 65. And I know a positive does not equal a negative. So I'm going to get a no on this front, which means that does not work. Again, right here, I'm going to get a positive 65 absolute value, which means that 65 does not equal negative 65. So neither does that. And so that's oftentimes what we'll see when we're trying to plug these things in. Now, with this one, I see an absolute value and I see a negative. So my first thought is to say, you know what? I've done it twice now. This one won't work. I'll get no real solutions. But the important part of working these things out is that we'll see that when I add 15, and those cancel out, I'll have an absolute value of y minus 4 is equal to 10. Now this can get valid answers. And so we'd go through our process of splitting it into a no change version and into a changed version, which would mean y minus 4 is 10 and y minus 4 is negative 10. Stay the same, change to a negative sign. We'd end up adding our 4, which would give us a y equals 14 that I would have to test out. And for this one, when I added my 4, I'd get a y equals negative 6 that I would have to try out. And again, remember from what we've done previously, I don't want to plug these in to the original equation. I want to plug it into the simplified form. So wherever I first isolated those brackets. And that's going to give me a absolute value minus 4 is 10. Absolute value minus 4 is 10. First number I'm going to plug in is 14. The second number is going to be negative 6. Let's see what they do. 14 minus 4 is the absolute value of 10, which is 10. That checks out. That's good, so this works. Likewise, my second check, absolute value of negative 10, turns into a positive 10. And so this also works. So what we want to do is we want to be careful of preemptively saying, well, that's a negative, it doesn't work. That's a negative, it doesn't work. That's a negative, it doesn't work. Because we can see that sometimes when we isolate it, we'll get a valid answer. Now, this one was positive, so we know both our answers are going to work. And also, another way that we could put these is we could say these are no solutions. That's actually the technically correct term. You could put empty set if you wanted to, but most of the time, no solutions suffices. But, so when we have this, we know that we're going to get answers. We know that we're not going to get answers. What's a way that we could tell or could not tell? What happens if we get it sometimes, but not all the time? Well, let's take a look at these. These are when I have x on the outside. So what I'm going to have to figure out is I'm going to have to figure out, is that positive or is that negative? Will this work or will this not work? And so what we'll do is we'll just have to try it out. Split it into the no change and the change, which means I'll have a 2x equals x, and I'll have a 2x equals negative x. Now, for this one, I'm going to subtract my x, gets rid of everything on the right-hand side, so I have x equals 0. I get to try out that number. On this one, it's not quite as simple. When I add my x, that goes away, so I have 3x equals 0. But again, after I divide by 3, anything, 0 divided by anything is going to give me 0. So I'm pretty sure that when I have an absolute value, I can get that equal to a 0. So both of these are going to give me valid answers. In fact, they're going to give me the same valid answer. I don't need to plug both of them in. I just need to plug one of them in. So 2 times something, which is a 0, is equal to 0. So if I work this out, absolute value of 0 is 0. And does 0 equal 0? Yes. So my solution is 0. But oftentimes when you get an answer where, let's say, one of my solutions would be a negative, I know that wouldn't work. And really the only way we're going to tell that is by plugging it back in. So let's try one more. Let's try this one. This is already isolated, so I'm going to go ahead and say split into my no change, which is a 3y equals y plus 16, and then into my changed version, where I changed the signs of both of these. So 3y equals negative y minus 16. There we go. And as I work this, I'm going to subtract my y, which is going to give me a 2y is 16. If I go ahead and divide by 2, I get y equals 8. Perfect. I'm going to try that one out. Now for the next one, I'm going to go ahead and I'm going to add my y. Cancel that out. I have 4y equals negative 16. And when I divide by 4, I get y equals negative 4. So now this might throw people for some loops, because I see I have a negative and we were put on high alert. But now if I were to plug that in, 16 minus 4, that's still a positive. So this could work. I just got to try it out. 8 plus 16, that's a positive. This could work, so I just got to try it out. Let's double check. Let's plug them in. So I have a 3 times something equals something plus 16. 3 times something equals something plus 16. This something is 8 and 8. This something is negative 4 and negative 4. So let's try it out. 3 times 8 is the absolute value of 24, which is 24. 8 plus 16 is 24. Yep, wouldn't you know it? My first answer works. And for my second answer, we're going to try it out again because remember, 16 minus 4 gives me a positive number, so I know it's possible. So let's try it. The absolute value of negative 12, which is 12. 16 minus 4 is 12. And yep, I got both of them to work. So again, we have to make sure that we're plugging these things in because having a negative value just exposed, as we learned earlier, doesn't necessarily mean it won't work. Having a negative answer doesn't mean it won't work. Most of the time, we're just going to have to plug it in. And so for this one, what I want you to do is I want you to go ahead and try this one. And then when you're done, I want you to unpause the video. I want you to see how you did. Okay. Both these signs change. Negative 3n, positive 24. Okay. So first off, I noticed that this looks like this could be a very big negative value. We're just not certain. This looks like this could be a relatively small value. We're not certain. So we're going to try them out. Either way, this looks a little iffy. I'm going to plug my negative 12 into here. I'm going to plug my 3 into this one. And let's see how we do. 5 times negative 12 is negative 60, which is positive 60. 3 times negative 12 is negative 36, minus 24. That's going to be negative 60. That one does not work. Well, let's try this one. 5 times 3 is going to be 15, which is 15. It's going to be a 9 minus 24. That's a negative 15. Oh, lo and behold, neither one of these works. And so we could tell that this didn't necessarily give off any sign that we haven't seen before, but when we tried to plug in the values, neither one of them worked. So our final answer was no solutions. And there we go.